Welcome to the Battery Testing Mentor podcast. My name is Johannes and here I discuss all topics around battery testing, battery safety, battery handling. Short, on the point and with practical advice. Also visit www.batterytestingmentor.com and sign up there for the summary of the episode. Also what I tell you today, I will summarize and you receive it straight with the release of the episode. And if you have any questions, comments, feedback, just reply on this email and you directly reach me. Today I go into a new topic, basically an old topic. I talked about battery testing, about these testing cube, these 3 dimensions in the episode 5, where we have the dimension of outside operation, inside operation, the cell module pack increase or like dimension, and the third one is the electrical, mechanical and environmental testing. And today I want to pick some cubes out of this and talk about performance testing. To be honest, it's basically just one dimension. Like the electrical testing, normally you do it inside the operation conditions. You can also do this outside, but you need a little bit different equipment for this, because if you do it outside, you basically constantly poke the cell or the battery and just try that it reacts. Like if you have a lion and you poke him and maybe one point he jumps up and attacks you. And then it's nice if you have some safety in between you and the lion. And the third dimension is cell module pack. This is as well like covering the whole range. All of these different levels are tested for lifetime, for performance, are tested in performance testing. The only difference is there again different machine, like slightly higher power or a lot higher power, different sizes, different weights. But so very generally speaking, let's go ahead and say we have this battery, be it a cell, a module or a pack. We have this battery and we want to test it. We want to simulate the performance, we want to simulate the lifetime. What do we need to do? First thing is, of course, we need to charge and discharge the battery. We want to simulate the real use, so we use some load profiles that can come directly from the field. It can be really recordings. Imagine again the electric vehicle where somebody drove around with the car and recorded really the power profile. But it can be also artificial profiles where you really go kind of bring together certain scenarios where you know that this, for example, ages the battery the most, or you really make sure that the battery can then perform or provide the performance that you need in certain situations, and you target then the profile really to this, that you can make sure in every situation you get this power. So basically, it's still charging, discharging. Sometimes longer charging phases, sometimes it's really very short. This is the first thing. Like if you pick now the cycler to connect the battery to, you need to make sure that the speed matches what you want to do. Like if you want to do a very dynamic driving profile with like changes every millisecond, every 10 milliseconds, you need a cycler that can react that fast. There are a lot of more things to consider when you talk about battery cyclers. The whole how it's designed makes an impact. Like there are battery cyclers that need to kind of stop at 0 ampere if you change from charge to discharge, or the other way around. So basically you do this step and then you have a very small step at 0 ampere before you change into the charging and discharging pattern. And then there are others where it goes through. And same when it does the jump, does it smoothly go into the target current, or does it oscillate a lot around this value before it narrows down? Also, does it need a long time to go there? Does it need a short time to go there? I mean, there are always compromises to make, but generally, yeah, this is one aspect. Other aspects are the efficiency, of course, how it's cooled, how the noise. I mean, there you go also in very operational aspects, which can end up, can you integrate the cycler into a lab management system? So you have the battery, you charge and discharge it. You, of course, need the proper cables, all the stuff connected. And then the next very important point is the environment. Like, you don't want to just put the battery somewhere on the floor and it's just at room temperature, but nobody really knows what temperature it really is. But you also need a climate chamber, or at least a temperature chamber, so at least something to control the temperature. In some tests, you even go towards climate and control the humidity as well. There you also need to make sure a lot of things like the power, you need to consider that when the battery is charged, there's waste heat coming off, so the chamber must be able to deal with it, to bring this waste heat out of the chamber. It needs enough space, it needs enough air change, that speed must be good enough to make sure that there is also really an homogeneous temperature inside the chamber. If you have a bad chamber, you might have at one corner of the chamber 5 degrees different temperature than on the other corner. Also, like really where the cells are, it can happen that, especially at low temperatures, if you have a bad chamber, that you build a kind of microclimate around the cells, and then your chamber says it's at minus 20 degrees, but your cell is at 0 because the heat is kind of kept around the cell, and the air circulation is not well enough to take away this heat from the cell. So then we have the cycler and the chamber. Is that all? Not yet. I mean, if in simple tests you have now taken care of the setup. What is very, very important is, of course, the measurement. You need proper measurement, you need fast enough measurement, you need accurate measurement. Because if you do tests, you want to have them repeatable. You want to be able to say, if I do the same test somewhere else, or even in the same location, I want to have the same result. And there are two things to it. On the one hand, the setup must be really well documented and clear, and it must be so well defined that you can just easily replace it somewhere else without some black holes where you say, oh, this was not defined, we don't know how it was done. And on the other hand, you need to measure the result, because only then you can make sure that it is really repeatable if you have all the data and can compare it and can then really say, okay, you did the same test, same setup, have the same result. And here again, if you have very fast tests, high like drive cycles and so on that are very fast, you need also fast measurement rate. If you have a drive cycle with like 100 or 10 millisecond change time, and you record the voltage only every second with 1 hertz, I mean, you get a feeling for it and you get a result, but if something goes wrong, you are lost in this data, because the voltages are not really precise enough to understand if the drive cycle has been run. So these are the core points. Now, there can come a lot on top. I mean, most obvious when you say measurement is a lot of additional measurement sensors, like hundreds of temperature sensors inside a battery, or pressure sensors to see how the battery behaves. Of course, you need to measure the voltage. inside the, like with the cycler and so on, and maybe also really measure every cell voltage. I mean, not only maybe, this is definitely needed, especially if you go to modules and packs. I mean, a test without measuring every cell voltage is almost like asking for a problem. But then there are other things as well, like a cooling system. This is not very often used on cell level, but especially at module level, it starts normally already in pack for sure, where you have then external cooling to bring away the heat, to simulate also how the battery is cooled in the final vehicle. There you also need to have a lot of things in mind regarding this cooling. It really can turn into a complex thing, especially if you have the pressure controlled and volume flow controlled, and a combination out of several things. And then another thing apart from the cooling is CAN communication. This is also something that happens or takes place mainly on module and pack level. Especially on pack level, it is very common. It also helps you to reduce the measurement need normally, because the BMS that is in the battery will measure quite a lot of values already and then send them out. And this is definitely very, very helpful. These are now the main functions that you need for performance testing. There is one very important thing, and that is safety. I didn't cover it. It's super important. It is also maybe worth once on separate episode, because you don't want that any major damage happens when the battery starts burning. I mean, in performance testing, especially if you're inside the operational conditions, it should not happen that a battery goes into thermal runaway. There should not be an accident. You can never 100% exclude it. And that's the tricky thing. Like, there's always a certain possibility that something happens. And we don't want that anything like this turns into really a big thing, into a catastrophe. And above all, we don't want that anybody gets harmed. Like, no person should be harmed by just some battery starting to burn during a test. And for this safety, you need things like fire extinguishing, like a pressure release. There are many aspects. Maybe it makes really sense to make a separate episode, because I see the time is running out again. Just wrap up now. We have here the performance testing. We have talked about performance testing. You need the cycler, you need the climate chamber, potentially a cooling system, CAN system. You definitely need measurement systems. And you need to make sure it's safe. If you want to have this into your inbox, then sign up for the email update on www.batterytestingmentor.com. And otherwise, I am looking forward to seeing you and hearing you next week again here at the Battery Testing Mentor.